To part one of what could be a many-part series covering the Queensland Maths Methods external exam, the first external exam of its kind in Queensland. In this one, I'm going to be looking at just the multiple choice from the tech free. It's 10 questions. You really want to allocate yourself about 90 seconds a question. So across these next 20 minutes or so, what I really want to focus on is not just how to do these questions, but how to approach these questions. Right from the very first question, you'll see that I'm approaching these in non-standard ways at times because you don't have a lot of time and you need to sort of keep your wits about you and use the format that it's in, the multiple choice format that it's in, to give yourself clues and to speed up the process. All right, let's jump into question one. Off with possibly the silliest question on the exam, question one. Now you shouldn't solve this like a year 12, you should solve this like a year 7. If you look here, you've got a square, roughly, that's 2 units squared, right? But this bit's been cut out, so that makes it less than 2. This bit's bigger than that bit that's got cut out, so a bit more than 2. And then there's this extra bit here again. So I think the answer is about 2.5, 2.4, something like that. Now, you should know that E is approximately 2.7 something. If you look at these four answers, 1 minus 2.7 is going to be negative. Our answer is not going to be negative. You don't have negative areas unless you're dealing with signed area. 2.7 minus 2, that's 0.7. That's not what I'm looking for. I'm looking for about 2.4. That's 2.7 minus 2 is just 0.7. No good. 2.7 minus 5 over 3. 5 over 3 is like 1.6. So 2.7 minus 1.6, that's not going to fly either. I hope this works. 2.7 minus 1/3, that's 0.333. 2.7 minus 0.333 is 2.4. That's my answer. Now, I don't know why they've written this question this way, because I don't think they want me to solve it that way, but that's how I'm solving it. What I think they want me to do is integrate between 1 and 0 the difference of the two functions, e to the x minus x squared minus 1, with respect to x. Now, this is multiple choice, so my working doesn't need to be amazing, obviously. You shouldn't worry too much about what you're doing here. All right, so that is going to be integral e to the x, x squared would be negative x cubed over 3. And then I've got negative 1. It should be positive x there. All right, and then we sub 1 in for x, we sub 0 in for x, we subtract 1 from the other. What do we get? We get e to the 1, which is e. We get negative 1 to the 3, which is negative 1 over 3. So just negative 1/3. We get a plus 1, and then minus e to the 0. E to the 0 is 1, so we do include that. But this bit's 0 and this bit's 0, so they're out. E to the negative 1/3 plus 1 minus 1, these cancel each other out. This is our answer, solved like a year 12, but we'd already done it, just like how a year 7 would do it. Moving on. Question 2 here, it's an integral question. Now the key, and a lot of people might not have realised this, but it's to split up this fraction into 2 components. So we can say that it's the same as e to the x over e to the x plus 1 over e to the x. And we're integrating all of that with respect to x. I should maybe put some brackets around it, but I'm not showing my working because this is multiple choice, so I need to do it fast. All right, so I'm finding the integral of e to the x over e to the x, which is 1, and then plus this e to the negative x, and with respect to x. Brackets. Okay, after that, the integral of 1 is x. The integral of that is this divided by negative 1, which is just going to end up being negative e to the negative x, and I get this plus c on the end. Now I should sort of look at my answers here. I've got this x, so it must be a, b, or d, so it's definitely not c. All right, and then I see this like to the power of negative x. This one has x times e to the negative x. It's definitely not that. That leaves me with this one here. That's the one I was looking for. That's about as far as we're going to go with that one. Let's move on. So another integral here. It's going to be 2 times, and we're just going to do the integral in a single shot here. So it's going to be 1 over, increase the power by 1, so the 3 becomes a 4. bring the derivative out of the thing in the bracket. So that's 4. So I have 1 over 4 times 4. And then I'm left with 4x plus 6 and increase the power by that. Now that 2 times 1 over 4 times 4, so 1 over 4 times 4 is 16. 2 times that is 2 over 16, which is 1 over 8. And I get 4x plus 6 to the power of 4. I check my answers here. I've got like a 16, an 8, a divide by 2. Maybe I've simplified wrong, but then I see this answer here, over 8. All right, so if I just I rewrite that in that way, that I'm in business. Now, luckily it's a multiple choice and they've all got plus C's because I forgot to put a plus C there. So it must be D. Now, if your integration is not strong, then what you need to do instead is look at all of these answers and see if when you derive them, you get the answer. So if I was to find the derivative of A, which we know, I think, is not going to give me the answer, but I can try it, right? So I can do 16 times the derivative of that, so 16 times 4, that's going to be like 64 multiplied by 4. That number's getting really big, so it's probably not that one. And if I've done that one and I feel like that number out the front's getting really big, then it's probably not this one as well, which would lead me to try this one or this one next. Okay, so if you're not strong on your integrals, try using your derivatives again. So if I was to use this one, I would say, well, bring the 4 out, bring the power out, so it's 4 times 4, bracket 4x plus 6 to the power of 3, all divided by 8. And then I get 16 divided by 8, which is 2 bracket 4x plus 6 to the power of 3, which was our original question. So I must be right, D is the correct answer. You can see lots of words on the page. This is a multiple choice question. It's supposed to only take you 90 seconds. So you need to think and read at the same time. So it says blah blah pulse rates, normally distributed. All right, so I'm looking at a normal distribution. Mean of 70. All right, good. Standard deviation of 8. All right, 8, 8, 8. Okay, maybe that helps me out. Which of the following choices describes blah, 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 pulse rate greater than 78? All right, so standard deviation, 78. I'm looking for something that describes this area. Determine the area to the left of Z equals 1. All right, they're talking about Z, so they're talking about standard normals. 1 here and 2 here and 3 here. All right. Determine the area to the left of Z equals 1. Well, that would be all this stuff. So no, I disagree. Determine the area to the right of Z equals 1. That seems like a really good candidate, so I'm thinking B at the moment. Determine the area to the right of Z minus 1. All right, Z minus 1 is here, so it's not that. Determine the area between these two. No, it's not that. The answer is B. All right, so this relies on your knowledge of the standard normal distribution and the relationship between means and standard deviations in the standard normal distribution. Draw a picture. Look at this question, equation of the tangent. So you've done 100 of them. Good idea to look at all of the answers. You'll notice they all look a bit funky. They've all got these e's in them. All right, so if you're trying to find the equation of the tangent, we're going to need a derivative, so f dash of t. And when you look at f of t, you see t times e to the t. It's a product rule. So if we let u equal t and v equal e to the t, u dash will be equal to 1 and v dash will be equal to e to the t. Which means that f dash t is going to be equal to this times this plus this times this. So t e to the t plus 1 times e to the t, which is just e to the t. All right, so there's our f dash. Now we want to find the equation of the tangent at t equals 1. So if I sub 1 in here, I'm going to find my gradient. So the gradient of my tangent is going to be equal to 1 times e to the 1 plus e to the 1. That's just e to the 1 plus e to the 1, which is 2e to the 1, and e to the 1 is just e. So I have a gradient now of 2e. All right. Now I'm looking for something of the form y equals mx plus c, not mx, mt plus c. All right, so I know my m is equal to 2e. I know that I'm looking for something at t equals 1, so I can sub 1 in there. If I knew a y value, that would be good. I can find the y value by subbing 1 into f of t. So f of 1 equals 1 times e to the 1, which is just e. All right, so I know my y value is e plus c. Now, that means that c is going to be equal to e minus 2e, which is negative e. Okay, so finishing it off, I know that y is equal to m, which is 2e minus 2et, because that's like my x value, I guess. Y equals 2et, and the c value is minus e. Have we got one? Y equals 2et minus e. The answer is B. So this question's a weird one. It sort of threw a few, even maths teachers around the place. If the probability of success in a Bernoulli trial is 0.3, the variance is. Okay, so Bernoulli trial, that should make you think of binomial distribution. A binomial distribution is a series of Bernoulli trials. What's weird here is that we don't usually talk about Bernoulli trial, singular, but that's the hint that the n, the number of trials here, is just one. There's one trial. Now, the variance is just NPQ. You might get like messed around here because you might think it's square root NPQ, but that's standard deviation, and we want variance in this question. All right, so what is it? Success is 0.3. I already said the number of trials, Bernoulli trial, is 1, and Q, or P minus 1, is 0.7. Okay, I look at 0.3, I look at 0.7, and the 1's not going to contribute anything. 3 times 7 is 21. All right, and there's one answer here that's got 21 in it, and it's this. So that's the answer. It's worth noting here that this is not the answer, but they've thrown it in there because it's the probability of success. It's not the variance. This is not the answer. They've put it in there because it's Q, or 1 minus P. Now, if I had to guess, I reckon 0.46 is the square root of 0.21. Calculator, it is. So they've done a good job of writing this question because they've put 3 decent distractors in it, but that is our answer. Question 7, look at my eyes when I watch this, when I look at this question. It's a probability density function, and then I look at the question. The probability that the component lasts between 1 and 10. All of this stuff up the top, it's like useless like context. You really want to be laser focused with these questions and get to the meat of them fast. So what do I know? Well, I know it's a probability density function. I know I'm looking between 10 and 1, and the probability density function is 1 on x squared. After that, it's just the grunt work of integrating it. That power up to the top is a negative. Increasing the power by 1, which means moving from -2 to -1, and dividing by that new power, -1, and then subbing 10 and 1 into, oh, actually, let's move the x to the bottom first. More sense because we don't have a calculator, so we're going to have to do this by hand. All right, so that's equal to -1 over 10 minus 1 over 1. Alright, so -1/10 is -0.1 because we're in an unfortunate position here. We need to do something with this stuff. And then we have -1, which is +1. So 0.1 plus 1 is 0.9. Okay, and I can see my answer here, so I'm pretty happy with that. I can guess that 0.1 was like if you'd got things reversed in some way, and these ones were if you'd gotten your calculation a little bit confused. but focus on what's important in the question, ignore the rest. When it comes to these questions, your mind's jumping from topic to topic to topic. So when I look at question 8, I look at the whole page and I immediately know this is binomial probability, because that looks a lot like the binomial probability formula. So now I'm in binomial probability mode. It really feels like I've got to read the question here, like fully. A test includes 6 multiple choice questions. Each question has 4 options. All right, so there's going to be 6 trials, and if each question has 4 options, the probability of success is 0.25. So even without reading the rest of the question, 6 trials, probability of success, 0.25. All right. If the answers are guessed, the probability of getting at most 2 questions correct is represented by. All right, so it's important to understand that that means the probability that x is less than or equal to 2. So 2 or 1, 0, 1 or 2 successes. All right, so that's what we're looking for here. 0, 1 or 2 successes. All right, this looks like 0 or 1 success. This looks like 0, 1 or 2. This looks like 1 minus something, and this looks like 1 minus something else. All right, I need to look more closely at this one to make sure that it's doing what I think it should be doing. All right, 6 choose 0, 0.250. So 0 times, yep, that looks right. 1 success, 5 failures. 2 successes, 4 failures. All right, that's the one I want. Done. You can dissect this question more carefully if you want to, but honestly, you've got to get comfortable with that kind of an idea, that kind of thought process. Completeness, I've put what each of those items represents down this side. There's other ways of writing that, but that's what those 3 represent. This one was pretty close, but it wasn't less than or equal to, it was just less than. Question 9 here, we've got something that looks a little bit like here, f dash x, f of x. And we should know how to deal with that. That's going to give us the natural log of f of x. But it's not quite like that. At the bottom of our fraction here, x squared plus 2, the derivative of that, or f dash x of that, is 2x plus 2. And we have an x plus 1 on the top, which is, if we were to multiply that by 2, we would have that on the top. And that's kind of what we do here. Question exactly as it appears here. And then I'm going to take this bit here and multiply it by 2. Now, if I do that, I get 2x plus 2, which is what the derivative of the bottom is. But then I've doubled my answer, right? So I'm going to have to then take that and multiply it by a half. Now that seems like an odd piece of working, but now what I can do is bring that half out the front. On that, I'm pretty much home free. So I've brought the half out the front. I've expanded this 2x and plus 1 to get 2x plus 2. And now I have it in this special form here, which I know should be ln f of x with that half out the front. Look at my answers here. You can see I've got one here, C, and that's what my answer is. Now you can obviously check your work by working backwards and seeing if you can get to this answer here. Derivatives, integrals, you can always work backwards and forwards. I just cannot believe how absurdly long question 10 is. This is multiple choice. We've still got another 10 questions to go. We don't really have a great choice here because it's unlike most questions I've seen before, but looking at this formula, it gets you in confidence interval mode. So you've kind of got to read the context, and I'll leave you to read the context there. But all of this is just nonsense, right? And then you get this table, and then it says an approximate 95% confidence interval for the probability that material A will break completely or show defects is given by this. What this means is that any information we've been given on B is immaterial. And in fact, any information we've been given on total is immaterial. So we really just need to look at A, broke completely, will break completely or show defects. So that's this bit here. All right, so the probability that, I guess the expected experimental probability of it breaking is 60 over 95. 60 out of 95. Okay, now we just need to look at our C, our N values, and figure out what I should be putting in for C and N. All right, so N is our number of trials, and our number of trials here is 95. It's not 200 because we want to know the probability that material A breaks, not that it is material A and it breaks. So 95 is going to be our answer. It's going to be one of these three. We can get rid of that one. All right, our C value. Well, our C value is the probability that it breaks, and I've already done that over here. It's 60 out of 95. So here is our answer. And you can see where the other answers come from. 60 out of 200. They're doing 25 over 35, 200. And then 140 over 200, they're doing like the complement of 60 out of 200, and doing 140. So you can see where those other answers come from. But this question, unfair, don't like it, but there's our answer. That is it. That is the Queensland Maths Methods 2020 tech-free multiple choice paper. I'm going to do another few parts where I get through the rest of the paper as well. What I really want you to see there is test-taking technique, not just how to do those questions, but how to think about those questions in the multiple choice. You don't have a lot of time, so you really do need to be thinking with clarity and picking up on the clues that can aid you in answering those questions, sometimes in fairly non-standard ways, depending on the question. All right, good luck.